Hello and welcome to my first video on this channel. In this video I will attempt to create a custom DIY 3D printed robotic arm. Now please keep in mind this is by no means a professional robotic arm. It is more of an experiment and attempt at creating one. I am planning on creating more versions that will improve on my initial design and be incrementally better. Okay, so let's get started.
On fire. On fire. If I say goodbye, then make me alive. If I say goodbye, then make me alive.
So while the arm is printing, I decided to put together all the electronics just to test out how everything works. First of all, I have here the MG 996 servo motor, which we will use to rotate the arm and in all of the joints. Next up are the 9-gram servo motors, which we will use to rotate and open and close the gripper. They are fairly common ones, often found in RC planes. Moving on, this is just a 5mm power connector socket to power the arm and the Arduino. Next we have here a Bluetooth module which we will use to send commands from a phone app via Bluetooth and hopefully control the arm. By the way, this supports the BLE feature, which stands for Bluetooth Low Energy, and this essentially means that it's going to consume very little energy when not active. And finally, we've got here an Arduino Uno. Now, in the final version, I will use an Arduino Nano, but for this quick test, I will use the Uno, which is easier to work with because it has these little handy pins. And finally, just some jumper cables to connect it all together. Okay, so now that's everything built, I think we are perfectly ready to move on to the phase of actually building the arm. I uploaded a simple sketch to the Arduino which tells it to move the stepper motors to 180 degrees and then back to 0. And I had a slight problem with one of the servos, but it just went away by switching the servo. So I will fix that maybe later. And yeah, so let's move on to the actually construction process of the arm. Okay, so now that everything printed and we have all the electronics figured out, we're ready to assemble the arm. So to start off, I just want to show you the main process of basically assembling this. So to start with, we have here this base which will support the whole arm, and you can see I already put in the connector. And so here's gonna go this metal rod which will anchor the whole arm to this base. I'm gonna have to cut it shorter so it just fits in, and then second it will connect, the metal rod will connect here, and this gear will be driven by a servo, so it will go on like this and essentially rotate around like this. Then on top of this there will be these two parts which hold two servo motors and basically act as the first joint for the arm. The servo fits in like this, and basically the arm mounts right onto this thing, onto the servo. So I'm gonna press it in like this, and it will rotate like so. There will be this part, the second segment, which will look like this. So I will first bolt this part into it, and this will hold a servo, which will then be directly screwed to this part, and this part will be supported from this side with a short piece of metal rod, just to anchor it and make sure it's less flimsy and it's more stable. Okay, so and that is the way I'm gonna be assembling this. So I'm not gonna bore you through the whole assembly, so I'm just gonna fast forward this.
If I say goodbye, then make me alive, make me alive. My heart's heating up, this love is on fire, love is on fire. If I say goodbye, then make me alive, make me alive. My heart's heating up, this love is on fire, love is on fire, on fire. On fire. If I say goodbye, then make me alive. If I say goodbye, then make me alive. If I say goodbye, then make me alive, make me alive. My heart's heating up, this love is on fire, love is on fire, on fire. On fire.
Everything is working now, and in order to control it, I developed this quick little app using the MIT App Inventor. As you can see, I can control the position of each joint manually using these sliders. There's also the option to store the current angles and play through the stored sequence. I have prepared a quick little demo sequence. So I will just press the play button, and off it goes. Just as a quick side note, you may have noticed that when the whole arm turns, it wobbles back and forth for a bit. Now that is because I accidentally snapped the 3D printed holder that holds the main motor in place. So I will either have to reprint it or probably bolt it down properly. Okay, so I'm now happy how the robotic arm is working. However, currently the electronics are all built on this cheap breadboard, which has really unreliable connections. So I think now is the perfect time to solder everything on these PCBs. So yeah, let's do it.
On fire. On fire.
Unfortunately, this video is getting a bit long, and I also want to just post it here to see what others think. In part 2, we will make this arm to pick up some things, and we will also talk about some possible improvements and attachment to make it do even cooler things. Please consider subscribing to my channel to support me and to not miss any upcoming videos. Thank you.